Hello everyone. Are you a Qt for Python user? Would you like to become a Qt for Python user? Then this talk is for you. Ever since the last Qt World Summit, we have had two new versions of Qt for Python, 6.3 and 6.4. Over the general course of my talk, I'll be introducing you to Qt for Python, how you can benefit from using Qt for Python as a C++ developer, as a Python developer, or in general as any developer. Following that, I'll be showing you some 5 cool features of the latest Qt for Python. Hence, this talk is titled 5 Reasons Why You Should Use the Latest Qt for Python. A little bit about me. My name is Shyam. I'm a senior software engineer for the Qt for Python team at the Qt company. If you want to refer to these slides later, you can actually find the slides in the following link here. Let's start with the big question. What is Qt for Python, or what do you actually think Qt for Python is? Qt for Python is the official set of Python bindings for the Qt framework. But it's not just that. The official set of Python bindings for the Qt framework is called PySide. PySide is a component of Qt for Python. So Qt for Python is an entire application suite. It encompasses much more than just PySide. I've taken the liberty of drawing a fantasy map so that you guys can better understand what Qt for Python is. I call this the world map of Qt for Python. And this world map is continuously growing with every release. As you see in this world map, one of these components is PySide, which is the official Python bindings for the Qt framework. Along with that, we ship many more tools with Qt for Python. One other tool is called Shiboken, which is the Python binding generator. It takes any C++ code, not just Qt C++ code, and brings it to the Python world so that you can use any of this C++ classes or function from Python. There are many other tools, like for QML development, you have QML-lint, QML format, QML type register, QML-ls, and a new tool called QML tool. Each of this tool is prefaced with the keyword PySide. So if you want to actually use this in your command line, you have to use PySide QML or PySide -QMLLs. There are other tools for project development. There's this new deployment tool. There are tools for widget development, UIC, RCC, and designer. And there are tools for translation and a couple of other utilities like QtPy to CPP, which is actually used for converting any Python code to C++. This tool is still experimental right now, but for basic Python code to convert that into C++, it'll actually work, I guess. So this next section, we'll be dividing it into 3 parts. In the first part, we'll assume that you're a Python developer. Why would you want to use Qt for Python? Qt for Python brings in the power of Qt, a very popular and powerful GUI development framework, into Python. And as per many surveys like Stack Overflow and TOB Index, Python is the most popularly used programming language right now. We try to follow the release of Qt for Python immediately behind the Qt releases so that all these new features like classes and function that gets added with Qt are also present in Qt for Python. In Qt for Python 6.3, followed by the Qt 6.3 release, we added the classes, Qt PyQML property value source, and a couple of modules like Qt NFC and Qt Quick 3D, and a couple of more tools. Like PySide meta object dump, PySide QML type register, and PySide QML-lint. Some of these tools are wrappers around the C++ tool, and some of these tools are completely new to Qt for Python to actually make Qt for Python development much more easier for you. In Qt for Python 6.4, we added the classes Qt login category, a couple of new modules like Qt PDF and Qt HTTP server, a couple of new tools like PySide QML, PySide deploy, PySide QtPy to CPP. I'll be exploring into more details on PySide QML and PySide deploy in the next coming slides. Qt for Python is also the bridge to other popular Python modules. As I mentioned in the previous slide, Python is the most popular used programming language right now. And this is owing to the fact that Python is extensively used in machine learning, data science, data manipulation, and image processing. This particular example that you see here was actually done with PySide. and demonstrate how PySide interacts with Matplotlib, a popular plotting library, NumPy, a popular scientific computation library, and scikit-image, a popular image processing library. All these examples can be found inside the examples directory inside the PySide repository. There are more examples that demonstrate how PySide can be used with other popular Python modules. If you go into the external folder inside the examples directory, you will find another example here, Widget3D with Matplotlib and NumPy, an example with Pandas, again, another popular data manipulation library, and a couple of NumPy examples and how NumPy works with PySide. Improving the support for NumPy is something that we worked very much on the last year, so that you can now use NumPy arrays directly as the argument to many Qt functions with PySide. Another example that we actually added a month back was an async example. This actually demonstrates how Qt for Python can actually be used in an asynchronous environment through a package known as Trio. Trio is again a multi-threading Python package or an asynchronous Python package. Pythonicity. Although Qt for Python is referring to all of this Qt C++ function, we try to cater to the needs of our Python developers in such a way that they don't distinguish the fact that Qt for Python actually refers to Qt C++ functions. For example, in C++, when you create functions, you generally use camel case, right? So if that comes to Python, all of these functions like set column count and set enable, all of these things become camel case in C++, like add widget and all. But we've added this, but then camel case for creating functions is generally not a very Pythonic thing to do, right? Because Python developers would rather use snake case for creating functions. So to please all our Python developers, we added this new import called from feature import snake case that enables you to use all these same functions also in snake case. We also added another import called from feature import true property. And if you're a Python developer, you know what Python properties are. And people in Python do not really use setters or getters anymore, right? So all these setters like set enabled and set spacing, they become simply Python properties when you use this feature here. So button.set enabled would become button.enabled. Another Pythonicity feature that we actually added in the 6.4 release is Pythonic enums and flags. If you're a Python developer, you know that Pythonic enums are slightly different from that of the C++ enums, and Pythonic enums is very much catered towards the needs of the Python users. Our enums, which we called as Shiboken enums, was actually a wrapper around the Qt C++ enums. So generally they were like C++ enums in the Python world. With this new Pythonic enums that we added, all the Qt C++ enums are now more based on the Pythonic version of the enums. Like they are very compatible, but then at the same time, this is also very compatible with that of the old Shiboken enums as well. If you're wondering if you have to make any changes in code, you don't have to make any changes in code at all. This just works just like that. So why should I use Qt for Python? As a C++ developer now, most of the benefits of Qt for Python for a C++ developer comes from the fact that Qt for Python is in Python. So all the developments of, all the advantages of Python comes into picture here. For example, development speed, for example, there is no concept of building in Python as opposed to C++. There is no build generation step. Pip is your friend. You can simply install libraries or packages like with pip install command. So if you want PySide, you can just do pip install PySide. In C++, you will have to resort to Con package manager or any other package manager. And of course, use CMake to actually bundle these things together. There is no compilation. There is no building in Python. and include what you want with import statement. Imagine that you have a Python module that consists of, or a Python file that consists of many different classes, and you want to use one of these classes in a different place. You can only import that particular class, not the entire module as such. With Python, you can write very verbose and simple code. For example, a signal slot connection to a Lambda function looks like this in Python. It's very verbose if you look at it. You create a button, clicked. When the button is clicked, it's connected to this thing. So when the button is clicked, this thing is called. In C++, the same thing looks a little more obscure. Not very verbose, I would say. Find performance from other sources. Sure, I totally agree. There is no arguing about the fact that C++ is much more faster than Python. C++ is like tenfold faster than Python. With C++, you can create native VHCs, which is definitely faster. But with the computing power of present systems, this can easily be overlooked, right? Because if you look at this example here, this is one of the examples called Tetrich example in PySide. And it's also present in Qt as well. Can you one of this is actually in C++ and another one is in Python. Can you say the difference? Can you tell the difference? Which one is which? Because the present computing power of system, even though C++ is much faster for many applications, you wouldn't actually recognize the fact that C++ is much faster. So why should you use Qt for Python as any developer? Firstly, documentation and examples. Something that we really invested over the last couple of years was to improving our documentation so that Qt for Python becomes much more easier for new developers to get started. We have even hired a documentation engineer over the last couple of months to actually explain things in more layman's terms. We've added a lot of examples, like I've shown you examples on how PySide interacts with all these popular Python modules. There are also many examples with each of the Python Qt classes or Qt modules. We have a very strong community behind us. We are very active in Telegram if you would like to join, and also in Metrics. And if you have any questions, you can also ask us through the mailing list here. So we try to answer our questions immediately, or one of our or the people from one of these communities would also answer the question very fast. Now that you have a basic introduction to Qt for Python and what the benefits are, let's talk about the top 5 features which I think are really cool in the newer releases of Qt for Python. First feature I want to talk about is the Python wheels. I call it Python wheels divide and conquer. So what exactly are Python wheels? I'm sure that many of you are imagining this right now, but these are not the wheels that I had in mind. So what exactly are Python wheels? Python wheels are essentially zip files. They are build distributables of the Python packages that makes them much easier to install. When you do a pip install PySide sits or pip install any other package, most cases what happens is that it downloads a wheel and it extracts this wheel into the site packages folder inside your Python installation. So when you do a pip install PySide sits, what it does is it downloads the PySide sits wheel. You can even see the wheel inside PyP here and the size of this wheel. You can see that the size of the wheel is pretty huge, to be honest. And when it gets extracted, it's gonna increase in size, right? So this is because the PySide sits wheel encompasses a lot of things. A lot of all the Qt modules that PySide exposes are in there, like Qt Web Engine, Qt Multimedia, all these heavy modules are in there. That's when we realized that we could actually divide the wheels into 2 different parts: PySide sits essentials and PySide sits add-ons. PySide sits essentials package consists of all the important Qt modules that can be used independently. For example, if you want to use Qt QML or Qt, you don't really need Qt Web Engine in most cases, and you don't really need to download such a heavy package like Qt Web Engine or Qt Multimedia, right? So you can simply do a pip install PySide sits essentials. But then if you want the entire package as previously, you can still do a pip install PySide like you used to do before. So when you do a pip install PySide, it downloads both of these packages. Or if you just want PySide essential, you can do a pip install PySide essential. One thing that we actually deliver with the commercial Qt for Python package is the new M2M wheels, which actually includes a couple of modules for M2Ms. And this is only available for commercial users right now. Feature number 2, QML improvements. Something that we really spent time on was to improve how you can use QML with Qt for Python. With Qt for Python 6.0, we added the add QML element Python decorator, which was synonymous to the QML element C++ macro. With 6.3 release, we added more Python decorators synonymous with their corresponding C++ macros like QML anonymous, QML attached, QML extended, QML foreign, QML named element, and QML uncreatable. If you want to know how to use these decorators or what these decorators mean, you'll have to read the QML documentation, but then we do have examples inside the PySide setup repository on how to use these Python decorators. In principle, imagine that if you have a C++ class or a struct that makes use of these macros like QML foreign or QML named element or QML extended mac, how does this translate into Python? In Python, you would have the same macros, but in the form of decorators here. Like here you have QML named element, which the named element's name is Q line edit. And in Python, that is also QML named element as a decorator right now, but again, Q line edit. Another cool utility that we ship with 6.3 release is PySide QML, which is similar to that of the earlier QML scene utility, which was later renamed as QML runtime utility. It is used for prototyping and visualizing QML files. What that means is that you can simply point this tool to the QML file and it's going to visualize it without you writing any Python code. This tool enables you to create pseudo QML Python plugins. What that means is that if your QML file uses QML type, which was defined in Python, and if this Python file is in the same directory as that of this QML file that you're trying to visualize, then it's going to find this file automatically. If this Python file is located somewhere else, you can simply add it through -i option. Let's see how this QML tool, PySide QML tool works in principle. So I took one of the examples that makes use of QML. This example is something that you can actually find inside the PySide repository. So I go into the QML file. I notice a type called PyChart, which is actually defined in Python. And you can actually see that right now. If I go into list properties.py, you can actually see PySlice is a QML element, and there is also a PyChart here, which is also a QML element. Now I just run PySide QML app.qml -i list properties.py. The list properties.py is not really required. It's going to find it automatically anyway. So because it's in the same directory as that of the QML file that is being visualized. Feature number 3, deployment. So how do you take a PySide application and create an executable out of it that you can actually distribute to the users of a certain platform? For this, we have created a new tool called PySide deploy. So this tool can be used for desktop deployment for Windows, Linux, and macOS platforms at the moment. It's based on another tool called Nuitka, which is actually a Python compiler. Nuitka converts this Python code into C code, which is actually linked to libpython, and then finally produces the executable. I mean, that is just a brief of how it happens in the background. Nuitka only adds the required modules in the sense that if you only need Qt core, it will only add Qt core. It doesn't add all the binaries from Qt widgets or QML or anything else. So this tool, like I mentioned, is a wrapper around Nuitka. So now the big question is, why do you need a wrapper around Nuitka? Why don't you use Nuitka directly? So what this tool does is it makes Nuitka much more easier to use. So it'll identify all the dependencies of your application, installs all the dependencies of your application so that you actually produce the most optimized executable, and also identifies all the Nuitka options that are required based on your applications. Because for QML, you need some separate option. And if you're using web engine, you'll also need another set of options and so on. So how do we actually use this application? It's as simple as running PySide deploy path to the main function containing the Python file. It'll identify all the dependencies of that main function and then package everything together. Pretty simple, right? So, and if you're actually running this tool from that of the application directory, and if your file containing your main function is called main.py, you can just simply run the tool just as it is. Another way to run it is using a -c option pointing to a config file. This config file is created the first time that you actually run the PySide deploy tool inside of application directory. So, and this config file is used to control many different options like which Python to use or where do you want to produce the executable and so on. At the moment, the QML executables are slightly heavy, but this will be rectified in the next release. So how does this work in principle? So I took one of the examples, which is a Qt widgets example. The only thing that I have to do here is to run PySide-deploy. It'll install all the dependencies and then run Nuitka. This takes a while, like 76%. And it creates a bin file. Since I ran this in Linux, it creates a bin file. And if you look into the directory, you will actually find the bin file there. You can simply run the bin file too, which is actually your executable right now. And this is something that you can distribute. This is the Tetris example that I showed you earlier. Feature number 4, cross-compilation. One of the coolest features that we had in 6.3 release was to cross-compile into Linux embedded devices. And so what exactly is cross-compilation? Cross-compilation basically means to compile on a host to produce binaries for a target platform, which has a completely different architecture. For example, if your host system is x86-64, and if you want to produce binaries for ART64, then that process is called cross-compilation. So why did we want to cross-compile PySide sets to all these Linux embedded devices? Firstly, we wanted to bring PySide sets into Linux embedded devices where a lot of cool UI development is happening right now. So this would enable easy UI development in embedded devices like Raspberry Pi. This cross-compilation was also the base that we actually used for deploying into other different platforms like Android. I mean, we are currently researching on that at the moment. And at the moment, we have been having success with creating PySide wheels for Raspberry Pi devices based on Arch Linux ARM and Manjaro ARM. That's because Arch Linux and Manjaro, the reason why we chose Arch Linux and Manjaro was because they already had the latest versions of Qt. And the one thing to mention here is that the host and the target should have 6.3 plus higher versions of Qt installed. So what are the steps involved here? Step 1 is to copy the sysroot of the target system. Copy the sysroot of the target system into the host system. And like I mentioned, both of the systems should have 6.3 or higher version. And once you have done the copying, you have to fit symlinks, turn the absolute symlinks into relative symlinks. All these steps you'll also find in our website under the Linux section. If you go to the Getting Started guide on how to build a guide, you'll actually find this as well. And you'll also find a code there to actually fits the symlinks. It's a Python script, you can just simply run it to actually fits all the symlinks. Step 2 is to create a toolchain file. This toolchain file basically sets a couple of CMake variables and generally controls how the cross-compilation process should work. So this sets the target architecture of the target, I mean, which with the target architecture that you want to produce the wheels for, target sysroot, which you actually copied in step 1. You also have to download a cross compiler for the architecture of the host. For example, if you're using Arch64, you have to download a cross compiler of Arch64. And you have to set some other variables here. In most cases, you can actually use this tool chain as it is. Just replace these two fields here, target sysroot and the cross compiler, which you actually downloaded. Once that is done, step 3 is to run python setup.py inside the PySide repository. And in this particular case, you will have two new options, which is CMake toolchain, which actually points to the CMake toolchain file, which you actually created in step 2, and a platform name, which is the platform that you're actually creating the binaries to. And that's it. That's all you need to do. And at the end of this, you will have PySide fields for the platform under consideration or the architecture under consideration. Feature number 5, Shiboken supports more. So as I mentioned in the initial slide, Shiboken is a Python binding generator. It takes your C++ code and creates Python bindings for it so that you can call this C++ code from Python. C++ as a language is also improving continuously over the last couple of years, and with each iteration of C++, you have this really new cool features. One of these cool features that we have with C++20 is the spaceship operator, right? So what exactly is a spaceship operator? So imagine that you have a C++ structure, a class, and if you want to implement comparison operators with other objects of that class, you will have to implement each of these operators, each of the 6 operators. With C++20, you just need to implement one of those operators. Shiboken now supports C++ code that has spaceship operators, in the sense that if you have code like this or a class like this in C++, Shiboken can produce bindings for that. Another cool feature that brings Shiboken to play along with the big players in Python binding creation like PyBind 11 or Boost Python is the support for std unique pointer, which is something that we did not have. If you look at the documentation of Shiboken on how to use Shiboken, you have to create something known as a type system file, which basically tells Shiboken to expose this class into Python. And to support std unique pointer, all you have to do is to add this code to your type system file, and your node is called smart pointer type, name unique pointer, type is unique, set a number of getters, and the main field here is the instantiations field, where you actually set the class you actually are using as a unique pointer in the C++ side. Here, the integer class is being used as a std unique pointer in the C++ side as a return type or as a parameter. Another cool feature that we support with Shiboken is std optional right now, which is similar to how you support std unique pointer. The only difference is that you have to change the name to optional, and again, the instantiations have to be changed into the classes that you're actually using with std optional, right? To give you a recap of the 5 features or the 5 reasons why you should use the latest Qt for Python, first thing that we discussed is the wheels. We have 2 different wheels, divide and conquer. QML improvements. We also discussed deployment. We also discussed cross-compilation and also discussed Shiboken and all the new cool features of Shiboken. So what is the future? Where do we go from here? Something that we are working on right now, as I mentioned earlier, is cross-compilation into other operating systems like Yocto and Raspberry Pi OS. And another thing that we are working on right now is, now that we support desktop deployment, we really want to support also deployment into mobile as well. So something that I'm working on right now is the Android deployment, and hopefully we'll see it in 6.5. WebAssembly research is also in the initial stages, so we are actually doing some research on how we actually bring PySide sits to WebAssembly, and async.io support is also something that we are working on. For those of who doesn't know, async.io is another popular asynchronous Python package, just like Trio. Resources. You can find all these resources of Qt for Python in the product landing page, and also the wiki page, and also the official documentation pages. Thank you so much for listening to my talk. If you have any questions, please post them in the chat. Either me or my team would actually reply to them. Thank you.